Hello, 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 hello. How are you? Okay, guys, we're carrying on with data handling or stats. And in this lesson, we're going to look at graphs. Okay, why are we using graphs? It's a better way to present your data. So we're still in presentation of data. And we're going to look at four graphs in this lesson. Okay, bar graphs. That is a scatter, what do we call it? I didn't write it down. So a broken line graph and histogram. Okay, we're also going to look at pie chart in a little later. So I think you've done these things. You know these things. I'm just going to kind of make sure you know what to look for. So you know what I'm looking for and I'm marking. Okay. So you need to label your axes. Okay. You need to label your axes. You can't just leave something here without a label. If you need units, as we'll see later on, you will also need to write down the unit. In this case, it's not. Now, and this could be, for example, rating of I don't know what service and appearance of a store. Okay, so what I'm trying to say is you also need a title. Okay, so you need title, you need to label your axes. Okay, in this case we've got basically a bunch of people, a lot of people gave a score of 1 to 5 for the service and appearance of a certain store, like in the examples we looked at. Okay, this is what we call a bar graph. Okay, you know a bar graph. You know that the axes must be, the scale must be consistent. So we have to go in the same amount. Okay, we spoke about that. Okay, now often in bar graphs, okay, by the way, this is the broken graph of the same. This is a broken line graph. Okay, it's the same data. I'm just trying to do it, but you can either draw it as a broken line, okay, or as a bar graph. Mind you, in science, we hammer you guys. We make sure you draw a line best fit. A broken line graph is not a line best fit. It is basically a zigzag, dot to dot, as they say in the UK. Okay, it's a zigzag, so it's a bunch of straight line. It's not line best fit as it is in science. So you can either do a bar graph or you can do a broken line graph. Now, what's missing currently in both my graph is a way to figure out which one is the service and which one is the appearance, because as I've told you, there's two kind of rating, right? There's 2,000 people said that they score 1, but what was the difference between the red and the blue? So I need to have some kind of I forgot the English name for it, but way to know which one is the service and which one is the appearance. So if you have colors, it works the best. Okay. So I can say, let's say, I don't know what, let's say this is service, the red one is service, and the blue one will be appearance. Okay? So if you have, you're not always going to have it, but if you have 2 bits on each score, you need to have a way of showing, I forgot the English name, to show which one is which. Okay? So that's bar graph, and that's broken line graph. Now, let's look at histogram. I'll just pause here to draw one for you. Okay, so now one thing you might have noticed is that the bars are not touching each other. I'm not talking about the blue and the red, but the blue and the blue and the blue and the red are not touching each other. Where sometime, I'm sure you guys seen, I'll draw it in red, sometime you might have seen where the graphs are touching each other. And the question is, when do we do this and when do we do this? This, when the bars are touching each other, we call the histogram. And we use histogram when the data is continuous. Let me just see that it's actually recording. Yeah, when it's continuous. So histogram are used for continuous data. Bar graphs are used for discrete. No, that's not how you spell it. Discrete data. What does that mean? Remember, that was actually the first thing I spoke of in the beginning of this chapter. Discrete data is something like a score. You can either get 1 or 2 or 3 or 4 or 5. Nobody can get 3.2. Okay? When we've got that, 1, 2, 3, 4, we don't have anything in between, then we use the bars away from each other to show that there's nothing in between. Okay? So that's a bar graph. The histogram deal with things where we have continuous data. So in this scenario, I took an example of, let's say I have, I'm asking motorists, people drive a car, how much petrol they use per week, I don't know, or per day, okay? Maybe it's more like per day. Okay, so I'm sending the survey, how much petrol do you use every day? And they somehow do this calculation, and I found out that between 30 or two people use between 30 and 40 liters. Okay, maybe it's like a week. That makes sense, more sense. So two people said they use between 30 and 40 liters. Four people said between 40 and 50. 8 people said between 50 and 60 liters, and so on. Maybe it carries on. Okay, so that's the kind of table we worked in the last lesson, right? So if I want to draw a graph, I have to use a histogram and not a bar graph, because if somebody, let's say, use 41 liters and somebody use 42, you can always have between it. You can use 41.5 liter. Okay, so it's a continuous data. It's not a discrete, and therefore the bars must be touching. Okay. Other than that, other than the bar touching, which is not the same here, everything else is the same. You need to have a title. So I wrote amount of petrol used by motorists. You need to label your axes, frequency, number of liters. Here, okay, usually in continuous data, in fact, I think always, as far as I can think about it, you're also going to have a unit. Okay, so not here. Frequency is just number of people, so we don't have a unit. But number of liters, or maybe I should have write it like this. Okay, amount of petrol. So petrol used. Okay, and therefore you have to write down what is the unit you're using here, and that's liter. And then you just draw your bar, it's not bar graph, it's kind of bar graph, but they're touching each other. Now what I should have done here, and I didn't, and actually in fact I'm going to spread it out a little bit more, because otherwise I won't be able to show you. Okay, so let's say this is 2, I'm just taking these, okay, 2 and then 4, and that's all touching each other, and 8, and I need to say, okay, that should be touching each other. Okay, what am I actually writing here? Here, I need to write down the class intervals. So the class intervals, and you can write it horizontally. I'll write it horizontally. I just copy whatever is there. So I'm going to say, you're on, can you see? Can you see? Can you see? Okay. X larger or equal to 30, smaller than 40. This one is X larger or equal to 40, smaller than 50. X larger or equal to 50, smaller than 60. Okay, and you do it for the rest. Okay, that's pretty easy. Okay, bar graph, histogram, and broken line graph. Let's move on to pie charts. Okay, guys, our last type of graph we're going to deal with is pie chart. And again, a pie chart is one of these things that we work on grade 8, 9. You're not going to see it after grade 8 and onwards. Okay, so here I have an interesting question that I've got. So when you pay for petrol, okay, our last question we spoke about petrol, your money that you pay in the pump goes to different people along the way. Some of it will go to the petrol station, but obviously they themselves had to buy it, so some of that goes to the oil refinery where they turn the oil into petrol. Okay, so some of it will go to the oil refinery, some of it will go to the oil company that managed to extract the oil from wherever it is. Some of it, in fact, a lot of it goes to the government as tax. So this is a table that shows us the percentage per liter where your money goes. Okay. So 31% goes to government, 50% goes to the oil refinery, where we turn the oil into something we can use. Oil company that digs the oil, and only 8% actually goes to the petrol station. So I'm sure you've seen this kind of information drawn often in pie charts. Pie charts are very good to see how something is divided between different people. So that will be really good. And you can probably imagine that the biggest part, and in fact it's easy to see that exactly half of the pie is going to be for the oil refinery. Okay, you can see it's 50%, so obviously 50% of the circle will go there. The second biggest one is the government. Okay, so we're going to write government. Okay, I know that's 31%, and at this point I don't know how to make the angle. We're going to talk about this angle in a bit. Okay, a bit smaller, quite a bit smaller. A third smaller is the oil company. Okay, and now I'm a bit stuck. So really I should have made that a little bit bigger. Okay, a third, yeah. 31% is almost a third. And almost a third should be something like this. So this is the slice for the government. Okay? And then the oil company, petrol station are divided the rest. The oil company has a little bit bigger than that, than the petrol station. So this is oil company, and this is the petrol station. Okay. So that's a pie chart. But obviously, I just drew it not accurately. I need to really know what, for example, angle. What will be the angle here? How much is this? What is the angle here? Here I know that this is exactly half, because 50% is half. But how do I know the angle? So this is what I'm going to ask you to do. Always add another column here. And what we're going to do is learn how to convert a percentage into an angle. Okay? So how do we do that? Again, I think some of you will just know the answer. But obviously you're not here, so I have to just say it. So how do I do it? I'm going to say 31% divided by the total amount. In this case, 100. So it's always going to be easy. Okay? So 31 divided by the total 100, and we time it. That's the fraction. That's the fraction out of the pie. 31 out of the 100. Now, I need to time it by the total number of degrees in the circle. How many degrees are in the circle? 360. So I'm going to time by 360. Got my calculator. Do I have my calculator? Here we go. Okay. So 31. Or in fact, I'm going to do 0.31, okay? Because 31 divided by 100 is 0.31 times 360. And I'm getting, I'll just round it up, okay? In fact, it will be a little bit of a problem if I round it up. So I won't round it up right away, okay? 100, yeah, I will round it, 112 degrees. Okay? Now, the next one, you know what, I'm not going to round that. We'll talk about that in a second, okay? So that's that. Now, 50 divided by 100 times 360, I don't need a calculator for that. I know it's 180 degrees, right? 11, so 11 times 100 times 360, and 8 divided by 100 times 360. I'm not even going to do that, okay? You guys can do that on your own, okay? I'm going to get an angle. Well, I might as well just do it. Okay, so 0.11 times 360, 39.6, and the last one, 0.08 times 360, 28.8. Okay? So now just a word about why did I keep these decimal places. If I round it up, then the angles might not add to 360. It might add up to 361 or maybe 359. So maybe it's best that you just leave it like that. But when you come to draw it, if I ask you to draw it, okay, if I ask you to draw it, then you use a plotting compass or your protractor, and then you can just round it up. I'm going to ask you to find 28.8. Okay? Now, sometime I'm going to ask you to do the opposite. Here, I gave you a certain amount. Actually, let's just change something a bit. Okay? Let's say I didn't have a percentage. Let's say it was just, I don't know, amount. Okay? And let's say it didn't add up to 100. Let's say it added up to 150. So I'm just looking at the situation. Obviously here it's not the case. It adds up to 100. But let's say it added up to 150. Then how would I make, how would that affect here? Well, all I'm going to do is 31 divided by 150. 50 divided by 150. So at the bottom here, I need to have that total. Does that make sense? Okay. Now I'll just convert it back to 100 because I don't want to leave something too long, which is completely wrong. Okay. And the last bit of this video, I want to find out what happened if I give you the other, this question in reverse. So I don't know the percentages. Let's say I don't know the percentages. This is percentages per liter. But what I do know is the angle. I know the angle. So you might have got a pie chart, okay? And you know that this is 180 degrees. This is 111.6 or 112. Let's say you know the angle and you want to find out percentages. How are we going to do it then? Okay? Well, what we're going to do is we're going to do it in reverse. So if I've got the angle, 111,6, I'm going to say, okay, 111,6 divided by the total amount of angles, which is still 360, it's always going to be 360, and I'm going to time it by the total amount here. So if I do that, 111,6 divided by 360, okay, time 100, what I'm getting is, give you some more space here, you don't have to give me that. Okay, what I'm getting is 31%. Okay, so that will be 31%. If I time 180 divided by 360 time 100, that's going to get me back my 50%. If I do 39,6 divided by 360 time 100, let's see, 39,6 divided by 360 and time 100, that will be 11%. And the same thing will work here. So you see, we can work from percentages, whatever on this column, to an angle, or from an angle back to here. And that's graphs. Cheerio.